one thing we could look at is we could say, well, fine, I've got this particular kernel deep in my neural network. It's really hard, given a particular image, to then look at the activations and see what this means. Maybe what I could do instead is say, what's this filter for? Like, what kind of an image would this filter fire for? Okay, a lot. What kind of an image would it be responding to? So how might we do that? Well, what we could do is we could take our random image. So we could take a random image. So take a 3x3 random image, and we could feed it into our neural network. And in this neural network, at any particular point, right, we might have, let's say, a convolution coming out of here, going in to the next layer. Well, this actually generates, right, a tensor. And we could look at a particular layer of this that we're interested in. So if we pull this out, this is a feature map. And we could say, I wonder what sort of an image would make this feature map really go wild, okay? Really get large values for this. And so what we can do is we can use a form of gradient descent. Actually, we're not going to use gradient descent. We're going to use gradient ascent. And what we're going to say is we want to be learning an image that will cause this to be as big as possible. So we're going to create a loss function, the sum of these values. So just the sum of all of the values in this feature map. And what we'll do then is we'll come up with a random image, we'll feed it through the neural network, we will calculate the loss, which is the sum of this specific feature map in this specific layer, sum it all up, and then we'll say, okay, let's calculate the partial derivative loss with respect to our random image. And now what we'll do is we'll update the image. So then what we'll do is we use gradient ascent rather than gradient descent because we want to be increasing this value. Perhaps we shouldn't call it a loss, but that's what we've used so far. So we will basically say we'll take the image, and by image what I mean here are the pixels, and we'll add to the image some lambda times the gradient. So this will tend to increase the loss. And we can do this over and over and over again, modifying the pixels in this image that'll cause this to fire brightly, okay? To really go crazy, okay? This is going to be quite on. So when we do that, we're going to then come up with an image here that we can look at. And this will give us a visualization of what this feature likes, okay? What this particular kernel is going after in this particular layer of our neural network and this particular kernel number, okay, or feature, where I'm using kernel and feature interchangeably. And we could do this for every single one of our features. And again, when we're doing this gradient ascent, right, so this is a plus, which makes this gradient ascent. So this is the first 64 channels. This is in VGG 16, I believe. And we're going to look at the first 64 kernels at each one of our convolution layers. So if we look at our first convolution layer, we see here, these again are the images that we created from gradient ascent, that this is the one that the first kernel responds heavily to. This the second, this the third, this the fourth, and so on. And as we look at them, we can see they're like little wavy lines or little diagonal lines of particular colors, and so on. As we move down next into the next layer, we can see we have a little more less fine-grained structure and more strong structure. So we can see here, for example, it likes a line at the bottom, or a vertical line on the right, or another vertical line on the right, or kind of a square around the edge. As we keep going, we can see more complicated patterns. So these sort of swervy lines, or these horizontal lines, okay, things like this. So these are what it really is responding strongly to. And of course, as we'd expect, they're different. We wouldn't expect to have two kernels which both respond to exactly the same kind of an image, okay, because that'd be a waste of one of these kernels. So we'd expect the kernels to diverge in some way during the learning process. Let's keep in mind again, this is a pre-trained VGG16, and what we're trying to get from this is, gee, as we look at the VGG16, what are each of the kernels for? And this is what's telling us that. We went through this gradient descent process for every single one of the kernels. Here, as we're going layer, we're getting more complicated. Okay, we can see here, I don't know what I would call this, kind of a leopard. Here we have these vertical lines and so on. This looks maybe kind of polka dot-ish. Okay, so we've, what else do we have? We have, again, sort of, yeah, more complicated type patterns. And so these are the first several of the convolutions. As we go farther down, you would see things like eyes, okay, or wheels, perhaps. Okay? So that's really tending to show you that we have, deep down in our network, something that is relating to eyes and wheels and stuff like that. So this is another way in which we can visualize convolutional networks. Figure out, for a given filter, a given kernel, what excites it most, what kind of an input excites it most. We learn that by going ahead and using gradient descent. Okay? I mean, I suppose there's another thing you could do is just feed in lots of different images and then try and figure out which filters get excited by that.